This is workbook 1J, which is vertical motion. Remember, there's nothing different about vertical motion at all. It's exactly the same as horizontal. All the rules are the same. So they tell us that a rocket fires its engine to launch straight up from rest with an upward acceleration of 5 meters per second squared for 10 seconds. After this time, the engine shuts off and the rocket freely falls back down to the Earth's surface. So they say here first, and I didn't include the instructions on here, but on your page it will say sketch a graph of the acceleration as a function of time from t equals 0 seconds to 10 seconds. So they actually give us a teensy bit extra, but we don't need that. They say only graph it to 10, but this is pretty straightforward. I'm just going to use a straight edge here. We start out at 5 and it says it's a constant 5, and so for 10 seconds, so it's never going to change. So you're just going to create a line basically straight across like that. So that is all you have for the first one. The second graph here, they say make a graph now of velocity versus time for the first 10 seconds. So again, we can ignore that last second there. So here's the thing, at time 0, we know we have 0 meters per second. And if we're accelerating at 5 meters per second squared, then after 1 second, we'll be going 5 meters per second. And after 2 seconds, we'll be up to 10. And that's a bit easier to mark. So I am going to mark those two. All you need is 2 points to make a line here. So I'm going to line these up and then extend it out like that. And so your line should look something like that for the velocity. And I'm going to keep this one around because we're going to come back to this one a few times here. So next part they say, in part C, they say, from the graph drawn in part B, determine the velocity of the rocket after the initial 10 seconds of travel. So we can see that right here, that after 10 seconds, we've gotten up to a velocity of 50 meters per second. That also makes sense because if you're picking up speed, 5 meters each second for 10 seconds, by the end you're going to pick up 50 meters of speed. Part D says, from the graph drawn in part B, determine the height of the rocket after 10 seconds. So how high it is deals with how much area there is under the curve. That will tell us the displacement. So you can imagine that we are concerned with this area that I am going to highlight right here. So that triangle, we need to find the area of that triangle. This is one way to do it. They do tell you to do it from the graph. So 1/2 base times height is the area of the triangle. So that's 1/2. The base is 10 seconds. The height is 50 meters per second. So 10 times 50 is 500. Half of that is 250 meters is the answer to that part. So on part D here, the height it gets to, the displacement, is 250 meters. So next part, they say in part E, make a claim about the numerical value of the acceleration 10.1 seconds after firing, when the rocket engines have been completely shut off. So the moment that we shut the engines off, we're going to just be free falling. That's going to be the only force on it. So we're instantly, our acceleration is going to be negative 10 meters per second squared, where the negative indicates downwards there. You could also say something like 9.8. Remember, that's accepted. And you could say down instead of negative. That would also be accepted there. And use the definition of free fall to explain your reasoning. Well, only force in this case is gravity. And that is the definition of free fall. The force of the rocket is now gone. And there won't be any air resistance, we'll assume, so it is in free fall. And then last part here, it says 10.1 seconds after the rocket was launched, indicate whether the rocket is moving upward or downward. So some people think because it's being pulled down, like, it's going to go down now, but it's still going upwards. It is just beginning to lose speed. So choose one piece of evidence and write your claim below. Well, 0.1 seconds, it's only going to have changed about, in that case, 1 meter per second squared of speed. We're already up to 50, so we're still going to be going up at about 49 here. So that really hasn't changed. Or another way you could point to it is if I bring back my velocity versus time graph, we will start to come down with a slope of 10. So by 1 second later, if I add this on here, we will have dropped by 10 meters per second. We'll be all the way down here. But we still won't have reached 0 meters per second. We're still going up, just not going up as fast as we were before.